Okay, today we're looking at the difference between alternating and direct current, and then we'll also be looking at how electricity is charged to our home. How would they figure out our cost? So, alternating current versus direct current. It says alternating current, or AC, is the current constantly changes direction 60 times per second. Example is electricity in our homes. It's cheaper and easier to transport large amounts of electricity over large distances. Direct current is the current travels in only one direction. An example of this would be from a battery. Okay, so um, because we get our electricity from a power plant, the power plant has a generator. It's basically a magnet that's spinning, and because of that magnet spinning, anytime a magnet moves or spins, it creates electricity, or it converts to electricity. So they have wire going within that moving magnet, and it causes the electricity to kind of move, let's just say, forward and backward multiple times. And this happens very, very quickly. And then that transports through our electrical wires. And like it said, the AC can travel much further with a lot lower resistance, so it's more cost effective. Okay. Also, when it's in AC, it can use a transformer to either increase the voltage or decrease the voltage, which is important when you have electricity traveling that long distance and needs to be kind of boosted, or going from the power lines to your house, it needs to be stepped down, which we talked about in the last session, using a transformer. So many devices, such as cell phones, laptops, etc., use DC, but can plug into an AC outlet when using an AC adapter. Okay, so you'll see a lot of times with those, with a cell phone, you have the little box thing that you plug in. That's converting AC to DC, so alternating to direct current. Also, if you have a computer laptop or something like that, a lot of times their plugs will have almost like a little cylinder on it, or some kind of box that's on it that's converting it from AC to DC. Okay. Some devices in our houses that use DC, you don't even see that conversion. Sometimes the conversion is within the device itself. Okay. An AC adapter changes the AC to DC and also steps down the voltage from 120 volts to the battery voltage between 6 to 20 volts. Okay. So it's lowering the voltage for those devices as well. So cost of electricity. As you can see over here, on the right-hand side, there's a list of different appliances that are within our house, and they have ranges of about what wattage or power that they use. Okay, like refrigerator, 600 to 800. You can see your central air conditioning systems, 2,000 to 4,000. That's why electric bills a lot of times go up quite a bit in the summertime, because your central air is kicked on. Hair dryer uses a lot of power, 1,200 to 1,500. So it kind of ranges there. Light bulbs are very small. So they use power and are labeled with the amount of wattage they consume. The chart to the right shows some common appliances and their wattage. So, calculating the energy use. You want to convert the wattage to kilowatts by dividing 1,000. So, for example, for a refrigerator, you would take 600. If it was a 600 watt refrigerator, divide that by 1,000, so it would be 0.6 kilowatts. Okay, or 800, it would be 0.8 kilowatts. So you're just dividing that number by 1,000. Okay. Then you're going to multiply the kilowatt by time in hours that the appliance is used. So, for example, if a coffee maker is used for 0.17 hours, which is about 10 minutes, 20 seconds, something like that, how much energy is used? Okay. So the energy use would be, you would take the coffee maker, and if you look on the right-hand side for a coffee maker, it ranges from 400 to 800. So let's just say 400 divided by 1,000. That gives us 0.4 kilowatts. Times 0.17 hours equals 0.068 kilowatt hours. Okay, so that is the energy that is being used. okay, by that device over that amount of time, and that's what we're being charged. Okay, so electric companies charge you for the kilowatt hours that you use. If electricity costs about 0.15 per kilowatt hour, which is about an average. Right now, it's actually down a little bit. I think it's about 13 cents. In New Jersey, it might even be lower than that, like 10 cents per kilowatt. But it fluctuates depending on the time of year and what's going on. Like right now with this whole coronavirus thing, the prices of electricity have, I believe, dropped a little bit. Okay. So if electricity costs are 0.15 per kilowatt hour, how much would it cost to use a vacuum for 0.5 hours or 30 minutes, a half an hour? Okay. So we multiply the kilowatt hours by the cost. Okay. So if we see here, if you take the vacuum cleaner, 700 is the low end of wattage. So you take 700 divided by 1,000, that gives us 0.7 kilowatts times a half an hour, or 0.5 hours, times the 15 cents per kilowatt hour. That comes out with a charge of about 5 cents. Okay. Oh, there we go. That thing keeps getting in the way. So yeah, it's 5 cents. Not much, but there's a lot of devices in our houses that are using a lot of electricity a lot of time. So, every time you turn on your light bulb, might be a few cents, but if you leave it on, it's going to be more and more. Same with your your air conditioning. You try to lower it or raise the temperature on your air conditioning so that it doesn't have to reach low, too low of temperatures. Because the more time your air conditioner is on, the more energy it's using. Not much you can do about the refrigerator because that's pretty much constantly has to be on. If you were to turn that off or unplug it, obviously it could spoil the stuff inside and defrost your freezer. So there's some things that can be turned on and off, but then there's other things that just will always have to be on, and that's going to add up your charges. So Electric Bill says homes with electricity meters which monitor how many kilowatt hours of electricity you use each month. The electric company then charges you for your total energy usage. Okay. My home last summer, we got solar panels. So the electric all the electric that we use spins the meter one direction, but then our solar panels actually put electricity into the grid, the electrical grid, and actually spin our meter the opposite direction. So they look at the difference of that. So if there's a really sunny month that we get a lot of solar energy from it, and we're using a lot less energy, then more energy is given to the electric company, and it kind of gets banked in there. So they know that they owe me energy. And then if the next month, if it's a really cloudy, crappy month, it's rainy out, and we don't produce as much energy, then they will take it from that bank. And then at the end of the year, when it's all said and done, if I use less energy than what I produce, then they would give me a check or money that's going to be the difference based off of the average cost of electricity. And then also big companies, let's say, like, for example, on a Walmart, something like that, a big company will actually buy clean energy from people that have solar panels on their houses. This is called an SREC, and basically the big companies, maybe not so much Walmart, but companies that are factories and stuff that are putting out a lot of pollutants, they need to buy clean energy so that way it helps the environment a little bit. So they'll actually go in and buy your energy from you, or the amount that you produced, and give money for that too. So it's kind of a couple benefits that I'm kind of learning as I go, having the solar energy. So, and that's it. Thanks a lot.